Let's have a look at this problem here. A die is thrown twice. What is the probability that a 6 is obtained on exactly 2 throws? Well, the key to this question is to be logical. What we're going to do is we're going to use a method called tree diagrams, where we work out a logical way of setting out. So we're going to have this branch, which means we get a 6. And we're going to have another branch. Let's just undo that. We have another branch, which means we don't get a 6. Down here. So here we'll have this as getting a 6 and this one is not getting a 6. Hopefully you remember this notation as being not 6. Now what's the probability of getting a 6 on a normal die? Well, we know that's 1/6. It's 1 out of 6 chances. And not getting a 6 is 5 out of 6 chances. Now it's the first die being thrown. So all this level here that we're looking at is the first throw. So we're looking here at the first throw. Now what we're going to do is see what happens on the second throw, given what's happened on the first throw. So we need some more branches, because we still can throw a 6 and not a 6 on the second throw. So let's draw some more branches. This is the one where I'm going to have another 6, and this one's going to be where, draw another line, where I don't have another 6. And then for this one, I'm going to draw a line where I get another 6. And I'm going to draw another line, another branch, to illustrate where I don't get another 6. So on the second throw, we can either get a 6 or not a 6, 6 or not a 6. So probably getting a 6 again is still 1/6. It's still 1 in 6 chances when we roll that die. And not getting a 6 is still 5/6. Getting a 6 is 1/6. Getting not a 6 is 5/6. Now let's see. We're looking at the probability that a 6 is obtained exactly 2 throws. So we throw it twice and we want a 6 in exactly 2 throws. So we need a 6 the first throw. So we're going to go this branch. We need that 6 here. And we need this 6 here. So therefore, 1/6 of the time we're going to get this 6. And after this 6, 1/6 of the time again we're going to get this 6. So therefore, the probability of getting a 6 followed by another 6 is going to be equal to 1/6 of, and another mathematical word for of is times 1/6. Yep, we have 1/6 of the time we get that, and then 1/6 of the time we get that. So once we've had that 6, that's only happened 1/6 of the time. 1/6 of the time again we get this 6. So we get 1/6 times 1/6, which gives us 1/36. Now let's just make the question a bit more interesting. Let's say what's the probability we get at least 1/6. So let's look at the way how we're going to do that. So I'll get another highlighter. I'm going to go for a green highlighter. At least 1/6. Well, we can get 1/6 here. And this is obviously at least 1/6. 2 6s. So follow these branches. And with 2 6s, we get at least 1/6. But if we follow this branch and then diverge down this branch, even though we didn't get a 6 on that second, we still got at least 1/6. We've got 1 there. Now there's another 6 over here, so that's at least 1/6. So let's go down this branch. Right, even though we got no 6 on the first one, but if we get a 6 on the second one, we get at least 1/6. So the probability of getting at least 1/6 is going to be this 1/6 times that 1/6, which you already worked out. 1/6 times 5/6 to get this branch, and 5/6 times 1/6 to get this branch. So let's just do the working for that. So 1/6 times 1/6 we've already worked out is to be 1/36. It's quite good to write the probabilities down the end here. 1/6 times 5/6, because of this once we have that 1/6, 5/6 of the time we get this no 6, and therefore we do 1/6 times 5/6, which gives me 5/36, Remember, when you multiply fractions, you do top times top is 5, bottom times bottom, 6 times 6 is 36. And we want this branch, top times top, gives me 5 again, and the bottom times bottom gives me 36. So probability of at least 1/6 equals 1 over 36 plus 5 over 36 plus 5 over 36. So 1 plus 5 plus 5, that is 11 over 36.